Greeting dear poster viewers. My name is Amirashkan Askari and I'm a second year PhD student from Department of Chemical Engineering and Applied Chemistry from University of Toronto. Today I'm going to have a poster presentation about my recent study titled Model Estimation of Indoor to Outdoor Migration of Volatile Chemical Products Emissions. So first of all, the background for these volatile chemical products, or as we are going to refer to them throughout the remaining of this presentation, VCPs, you know that the recent groundbreaking publication by Brian McDonald and co-workers showed that during the recent decades from before 20th century to early times, because of the strict and ongoing efforts to make better and decrease the emissions from classical sources of emissions that are mostly related to fuel combustion and transportation, their relative importance to determine the outdoor air quality has decreased. But on the other hand, different kind of volatile chemical products such as pesticides or personal care products are being more and more used due to the modern lifestyle, and also because such kind of controls is not practiced for them as it is practiced for fuel related sources of emission. It seems that their emission factor is by far higher than most of the sources that are related to fuel combustion, and they are nowadays playing a more important role to determine the outdoor air quality. So our idea in this study was to make a bottom-up analysis to find out about, first of all, how much emission of VCPs is occurring in Canada. To do so, we chose the year 2015 because enough economic statistical data are available for that year. So we referred to governmental agencies like Statistics Canada and also non-governmental ones like Statista to gather economic data, and by finding out how much Canadians spent on different VCPs in 2015 and dividing those spendings on the average unit price of each product, we could make some rough estimations about the different weights of VCPs that were used in different sectors, both by consumers and also in industry. But one thing that makes a distinguish between VCP emissions and the emissions that is being done by classical sources related to combustion of fuels is that in many cases VCPs are being used in indoor confined spaces. Such VCPs are normally called consumer VCPs, whereas the other ones that are being used outdoors are industrial ones. So why is that important? As you may know, indoor spaces, because they have an elevated ratio of surface to volume, and also because the lack of sunlight as it is present in the outside, and also limited air exchange with outdoors, it has some differences with the outdoors in terms of the air quality concentrations. And if we want to consider those implications in terms of the indoor VCP emissions, it seems that when VCPs have their emissions at indoor spaces, these emissions, before they migrate to outdoors and contribute to the ambient air quality, are somehow altered or changed, both due to indoor chemistry and also indoor partitioning with surfaces. So our future work is going to deal with indoor partitioning, but still for this presentation, I'm going to be more focused on the role of indoor chemistry. So we want to see that the different reagents that are present indoors, how much they change the initial VCP emissions before they have the chance to migrate outdoors. And the significance of this study is that we may have some judgment that how much our original emission inventories are accurate for assessing the air quality implications and consequences of VCP emissions. For example, if we want to have some kind of judgment about SOA potential or ozone potential, we should know that what are actually the emissions and species that are migrating to outdoors. Are they originally the species that were emitted by the VCPs, or they have something else that are products of reaction of VCPs with reagents present indoors? So you can see here our estimation for the amount of emission of different categories both in Canada and United States. So I have presented both the nations here just to show that for a typical Western country that is implementing policies to control their air and improve the air quality, the trends are almost the same, although the absolute amount of emissions is sometimes higher or smaller related to the size of the industry and also population of the nation. But the thing that is key in this slide is that for the yellow part of the slide, you can see that the emissions are either similar to or at least comparable to the other half of the graph that is related to fossil fuels and combustion related sources of emission. So the message that we are getting is that it seems that VCPs are playing a more and more important role in terms of the outdoor air quality. But our other question was that how much of these emissions, especially those that are occurring indoors, are altered before they are present in the outdoor air and have some contribution in the ambient air. So this is the thing that we can see it in this graph. Here I have sorted from the highest to lowest the different emissions along with their uncertainty for different categories of VCPs. But for each of them, you can also see that how percentage is emitted outdoors, and from the remaining percentage that is emitted indoors, how much reacts and so transfers to outside in an altered way, and how much transfers to outside without any change. So you can see that for some of the VCPs, because they are more related to industry like degreasers or paints and coatings, actually most of the emissions is happening outdoors. So we should not be that concerned about the role of indoor phenomena. But for some of them, this outdoor emissions is really small, even smaller than 40%, like air freshener and printing inks. And at the same time, you can see that the indoor percent reacted is also a significant amount. So you can see that for about half of the VCPs, indoor chemistry alters more than 50% of the indoor emissions. So it is important to reconsider our emission inventories because of these reactions. So in conclusion, we saw that VCPs are estimated to have had a significant contribution in the whole 2015 emissions, both in Canada and also other nations such as the United States. Also, because about half of the VCPs are being used at indoor spaces, indoor phenomena should be especially considered to assess the effect of VCP emissions on ambient air quality. And at last, indoor gas phase chemistry alters more than half of the indoor emissions for pesticides, paint and coating products, adhesives, sealants, air fresheners, cleaners, and polishes. And for future works, first of all, we are going to decrease the uncertainty by referring to new economic data, and also we are going to include the effect of partitioning to make our model more accurate. Also, because different geographical regions have different building attributes, we are going to also include that one. And at last, because this is a modeling work, to make it constrained and more accurate, we are going to take some experimental samples both from indoor and outdoors to try to constrain our model. Thank you for your attention.